Hello. In this video, we are going to go through Learning Target 5.3.3, which is on proportional relationships. And specifically, we're going to learn about three proportional relationships. And you are going to need to know the theorems and then how to apply them. But how to apply them is super similar for each one, so that is pretty nice for us. But you do need to know the difference between each type. So there's going to be three, so I'm going to draw three columns. And the first is called the Triangle Proportionality Theorem. And the Triangle Proportionality Theorem basically says if we have this picture, and these lines are parallel, then these side lengths A, B, C, and D are cut proportionally. And so if we have this, then we know that A over B equals C over D. In other words, if these lines are parallel, then these sides are cut proportional to each other. And the nice thing about all of these proportionality theorems is that while there's like the theorem way to do it, it's actually pretty hard to mess up the proportions. You just have to make sure you create a pattern, and I'll show you that when we do a couple examples. So it is nice because you have kind of this safety net of how to set these proportions up. And almost every way you can set up the proportion is correct. So this is our first one where we have parallel lines, it cuts them into proportional sides. The second one is just the converse of that theorem, so the opposite, so converse of triangle proportionality theorem. And so the converse just means that we flip the if-then statements. So if instead of having this picture we have, it's the same picture but don't draw the parallel sides. We don't know that they're parallel yet. So if we have that picture and we know that they're proportional, so A over B equals C over D, then we know that those sides are parallel, so pretty much the exact opposite of the triangle proportionality. To be able to say that these are parallel, we do have to draw this picture again, but label the corners. So I'm just going to do a quick picture with it, label it G, R, P, S. And so in that case, line GP is parallel to line RS. So even though we're learning three theorems, two of them are the opposites of each other. So if you're given the parallel lines, it's the triangle proportionality where you're trying to prove that they're proportional. So this is your goal. So you have a triangle, you use the proportion to solve. If you already have the proportion, then it's the converse, it's the opposite. So now we got one more, and that is the two transversal proportionality theorem. And this one's pretty nice because we have it named very well. We're going to have two transversals. And so to draw this picture, you are going to basically draw three horizontal parallel lines. Oops. And then we have two transversals, so like this and this. And we have these labeled as A, B, C, and D. So although this is like different, like this is not a triangle, it looks kind of similar to a triangle, and a triangle is just a version of the two transversal proportionality. And so we treat it exactly the same, and the conclusion is the same. So if you have this situation, then we know that the ratios of A over B equal C over D. Same conclusion as the first one. So if you need to pause it to get any of that down, please do so, but let's go through a couple examples of these theorems. So the first example that we have, I want you to pause the video and then, or as soon as I draw the picture, you pause the video. And then make sure you have the picture as well, because I am going to go kind of fast with the picture. So in this picture, we're trying to find the side US, and I like to label anything that I'm missing, anything I'm trying to find, with a variable that's not one of the letters used. So I'm just going to use X for this one. And this one is the Triangle Proportionality Theorem, because we are given a triangle and we are going to use these proportions to solve for that value. And if we have these two parallel lines, we know that the proportion of A over B, which is this and this, is equal to C over D. But like I said, as long as you have a pattern, you can't really set this up incorrectly. So what that means is, like, the true definition tells us to do like the top of the triangle on the same side and then the bottom on the same side. So 10 over 4 equals, and then same thing over here, top of the triangle on the same side and then bottom, 14 over X. But you could also set it up like the complete opposite. So you could do this like 4 over 10 equals 4, or X over 14, so just like flip both of those. Or you could do like the top of the triangle over the top of the triangle, so 10 over 14, and the bottom of the triangle over the bottom, so 4 over X. As long as you don't like go across, or like for us, you know how I started on the top and then I did the bottom, and then I started on the top and did the bottom. As long as you don't do like top and then bottom equals bottom and then top, you'll be fine. So just kind of create a pattern and stick with it, and make sure you don't like go across. And once you have your proportion set up, it's a pretty easy cross multiply and solve. So we have 10x equals 56, and we divide to get x equals 5.6. And if you did this one, you would see the exact same next line, 10x equals 56. And so what I like to do is, although our pictures, we can't trust them all the time, usually they're good enough, they're close enough, and I like to make sure this is at least reasonable. So looking at this line, 5.6 does seem fairly reasonable for this problem. So this is my answer. And it usually asks you what theorem you used, and we used the Triangle Proportionality Theorem to solve this one. So let's do another. In this one, we have another triangle. And this problem is asking us if DE is parallel to BC. And so if we're given a triangle and we do not know if the lines are parallel, this is going to be the converse of the triangle proportionality. And for this one, we don't even have to like solve for missing values like we just did because we have all of our values. What we need to prove is that these are proportional. So you want to do the same thing where you do like make a pattern. So 8 over 12 and then 10 over 15. So top over bottom, top over bottom. And then you want to use your calculator and see what those equal as decimals. So 8 over 12 gives me 0.6 repeating. And so does 10 over 15. And so if these match, then our lines are parallel. And we use the converse of the Triangle Proportionality Theorem. So you just want to make sure that the ratios are equal, and sometimes like you don't even need to write this down. You can just do it in a calculator, make sure that they're equal, say yes, and then know why. And we got one more. So this last one, we're going to look like a 2 transversals. So we're going to do 3 vertical parallel lines. And then we're going to have 2 transversals. And it wants us to find x. And so in this one, we treat it exactly like a triangle. So we just want to make a pattern. So we can either do like this left chunk, so x over 12 equals 12.5 over 15. Or we could do like x, like the top, x over 12.5 equals 12 over 15. As long as you keep the balance, you'll be fine. So I'm going to do x over 12 because it's kind of already set up like a fraction there. Equals, and then because I started up here, I need to start up here for my second one. So 12.5 over 15. And so then you are going to cross multiply to get 15x equals 150. And divide to get x equals 10. And again, I just want to look at my picture and see if 10 might make sense. And you can see like I have 12.5, 15, 12. 10 is like a normal number for that to be there. If it was like 30 or something, I might get concerned, or vice versa. If it was a very small number, I might get concerned and go back and double check to see if I set my proportion up correctly and then if I solved correctly. And so this theorem is the 2 transversal proportionality because we had 2 transversals. So those are the 3 proportionalities you're going to need to know. But like I said, there's a pretty big safety net in setting these proportions up correctly. It doesn't need to be exactly like the theorem says, because the nice thing about proportions is that they make like lots of other proportions work within the problem. So just keep a pattern and you will be able to solve these just fine.